Well, hi, good morning, and thank you so much for joining me in my shop here. Today is June 21st, and it looks like a pretty nice day outside here. But tomorrow they are promising very high temperatures and stormy weather at the same time. Okay, well, thank you very much for joining me as I'm trying to drive out the last bugaboos that are in this radio. Just a couple more yet. Tone control still doesn't seem to affect the tone at all, and the antenna connections don't seem to work the way they should. There's also a capacitor that came off the antenna system, which I have not reestablished, and so we can look into that too. But first, I think the tone control. Interesting things happen with the volume control. I discovered that this radio does not match the schematic exactly. And I guess that's not too surprising, because no doubt as they built these things, they changed their plan, partway through a production run, and so you'd have a series of slightly different radios coming out of the factory. And this is probably one of the changes here, which was affecting the volume. And what I did was I just followed the schematic. I hadn't seen that this was a little bit different than what the schematic shows. In this case, the schematic just shows a capacitor coming over. But in fact, there's two taps on the back of this volume control and a resistor involved. And it does not appear on the schematic. So for now, what I've done is I've cut away the capacitor, and this has boosted the volume a lot in the radio, back to what I would call normal. I'm just going to leave it like that. For now, there's no reason to fret over this. The effect of this part was to, and I could be wrong about this, but to boost, or in effect, boost the bass when the volume is turned down. Now, you can't boost things without an amplification. There's no amplifier involved in this. So generally speaking, what you do is, if you want to make something bigger, you make the other stuff smaller, and then it looks bigger. So in the case of a radio like this, you would knock the treble down to make the bass more presentable. And when you do that, if you turn down the treble and then turn up the volume to get the same treble again, now the bass has been boosted. That's not what's going on here. That would be a combination of these two controls, the tone and the volume. This is kind of like a hands-off sort of approach to trying to resolve the issue at low volume. So I probably got this explanation quite wrong. So if you're really interested, you can look into it in more detail. For now, let's just say cutting this capacitor out has improved this radio tremendously. So the volume on the radio tremendously. Now the tone control is still not working. So having learned a lesson that the schematic may not match, and some of these capacitors I took out, I could not read the value on them, so I just used the schematic value. That could be what's happened here with the tone control. Now there's a capacitor to ground here. That's all it is, just a capacitor going to ground with a variable resistor. And you're just turning down the treble by sending it through the capacitor to ground. What are the chances that the capacitor I'm pointing at it here is just way too small? That the one that's on the schematic is too small, and it needs a much bigger capacitor in there. Maybe double the size or something of that sort to get the tone effect. Because right now there's no tone effect from this. I can turn this. Good show. I can turn this all I like, and the tone sounds the very same no matter what. So all I can imagine is that this is way too small. I checked the value of this capacitor, I desoldered it, and checked it. It's good. So it is what it is, but it just may not be quite the right thing. And that was the sound of this guy jumping up here. Here he comes, running around. Here he goes. Okay. So because all the other tests I did on the tone control indicate everything is okay, the only thing that's left is incorrectly sized capacitor. Why don't we take another look at the schematic there? I think it's a 0.005 that was in that position. Okay, here we go. Okay, so here we are, 0.005. Right there. That's my cat stomping over my keyboard. Well, what we can do is we can kind of stick in temporarily other capacitors. I have, I got a capacitor. I got the thing to do. So don't worry, I'll remember how to speak at some point. I got something here that I can use to do this this little experiment here. Okay, did a little more thinking here. Oh, jeepers! What happened? Cat fell down. This capacitor here, 100 picofarad capacitor. I replaced this little capacitor. It's also going right from the plate to ground, same as this. What if this guy? What if I put the wrong size in here? What if it's not supposed to be there at all anymore, which I doubt, because the schematic doesn't match. Excuse me. What are you chewing on over here? Stop chewing right away. This guy would have the effect, if it's too big anyway, of drawing down the audio signal. Its real intention is to take away any radio frequency signals that are left here, that have made it all the way through the radio. And it's trying to snuff them out here. So this could be essentially like having the tone turned down all the time. If I remove this capacitor, the radio will not suffer. If a few harmonics go through, it's not the end of the world. I can remove this capacitor, we can see what effect it has. I could play the radio, cut this capacitor away, or disconnect it, and see what happens. Did I put the wrong size in? I kind of doubt it. I really doubt it very much, but it's possible. Okay, so that's the investigation point right there. That guy. Let's go look at the radio. So this capacitor is small and hard to see. How about a little more light? It's this one here. Well, I'm simply coming from the plate terminal over here and going to ground on another grounded terminal on the other side. Looks like I put it in there pretty good. So this box, by the way, this is called a decade box. See, it says capacitance substitution box. It's commonly called a decade box, but that's not quite the right name for it either. But it's a capacitor, and I can select the value of the capacitor in there. So I can put this into the tone, like across the tone capacitor, and I can increase the amount of capacitance. I can't decrease it. I can increase it, and we can find out if the capacitor is undersized. But first, what I really think is, I think I'm going to have to stop my cat. So hopefully we're going to be using this antenna at some point, and he's busily chewing the cord I got plugged into it. He's a radio cat for sure. Bert, you've become a radio cat. Maybe that's not a good thing. That may not be a good thing. Okay, so removal of that capacitor. I don't really want to just cut the wire because I have a hard time reconnecting it afterwards. Can I see the size of it with a camera? Well, let's try that. Grab my camera here, my little camera. And just maybe the size is visible on here. Well, it's not like that. Look at my terrible. Oh, look at this. Is easy to get off here. I can probably get this off pretty easy. Just not that. I'm going to take manual control of the focus of this camera. Whoops. I almost did it right. Okay, manual control. There's a pretty bad soldering in there. It's a very hard area to see. But as crummy as all that looks, it's probably electrically fine. The thing is, it's not that something isn't connected. It's that you think what's connected is too much. There we are. Okay, down here. This is what I want to grab here. So I cannot see this directly. I am looking in the camera view. I just want to pull that piece across. These are not very strong pliers. Let me get the roots in here. Can't get it. Okay, what we'll do, this is very awkward in here. I'm going to have to just grab this wire. Luckily the wire is very light. Bends very easily, so I should be able to just yank it right off there once I get it desoldered. Okay. Just turning on my soldering iron. While it's warming up, let's look around at some other stuff here. Once I have the camera shoved away in the radio. Okay, we should be plenty hot by now. Cannot see what I'm doing actually. Come on off. Looks good. So I've disconnected the capacitor, whose job it is to quell RF and the audio harmonics, possibly. I don't think so though. And we're wondering if that capacitor, oh, maybe you can see the size of it now. If that capacitor is 110J, so isn't that 110 picofarads? Which is 100 picofarads, which is the size. I should test that capacitor, I think. Maybe it's defective. It's not exceptionally likely to be the case. Okay. $107 picofarads. It is what it is, that's for sure. Certainly matches the schematic and everything. Can that possibly be the... No, I just don't think it can possibly be the problem. It's up and free now. We're going to give it a go. Okay, so what's the status of the situation? The status of the situation is, I believe everything is good to go. Famous last words. I can see the dim bulb there. Get rid of the squeak. Whoops. Maybe not. Okay, radio. Come on, radio, where are you? Once again, low voltage. Get fooled by that every time. Come on, radio, what are you doing? Not supposed to be like this. What happened here? Speakers in. Taking that capacitor out can't have done this. It's behaving as if there's no high voltage in the radio. I glance at the magic eye and it's dull, but I cannot see any green in it at all. That would suggest no high voltage on it. You know, what happened? That's crazy. But let's go to square one here. It's there all right. 275 volts. Hello, radio, hello. Come in now, come in. You should be making lots of noise. And we'll pop in there. Oh my god, what the heck happened? How does this happen all the time? It can't possibly be that little capacitor. It would make the radio go silent. How can that possibly be? Oops, wrong control. Pan switch. We're on the broadcast band. And it's just stone silent. Did I do something else to this radio and forgot? I put a different tube in it, but didn't I operate it after that? I put a different tube in it. Okay, what I'm going to do is I'm going to tap the grid cap on top. See this new camera I got? If you shake it too hard, it does what it did just now. It just stops. So I can just reset it, but hopefully it doesn't do that when I'm not looking. But now, what did I say I was going to do? Oh my gosh. Push buttons. The push buttons aren't right. Maybe that's the problem. So we should push in the tuning button. And I'm just scared to put my finger on the chassis while pushing these buttons. Okay, it's locked in. No difference. Man alive, what'd you do to it? Oh yeah, we were going to deal with the tubes. Right. Mr. Doesn't take much to distract me, does it? That's because I'm not coffeeed up yet. Okay, touching the grid. Not a sound. Touching the next one. Ooh, nothing there either. Should have heard the come out of the speaker. Let me stick my ear on that speaker there. There's a very slight buzz coming out of it. The only change I made was putting in a different tube. tube I put in, I tested it. It tested good. Touching the cap on that tube doesn't make a sound, but then neither does anything else. This capacitor could not be responsible for this. Could it? So I'm going to reconnect it. I'm going to use a pair of pliers. Wire down, please. Okay, making sure I'm connecting it to the right spot where it more or less came from, right here. It's not going to make it there. It's not going to bring anything back. Where'd it go? Is there something I'm forgetting? What did you do, you nasty cats? Well, I mean, I have to start troubleshooting this as a dead radio. I don't really know where'd you just come from? You hightailed it out of here. Literally hightail. You missed them. Yeah, the cats have done this. Well, nothing's coming to mind as I stand here, so I'm going to shut down here. And take a little break, get my coffee ready, and try to think of what the heck has happened. Well, I really have no clue what has happened to this radio. So it was working, turned it off, came back the next day, turned it on, doesn't work. The most likely thing is a tube failure, like a heater in a tube failing. Even that, but that, you know, most likely, it's still just a wild guess. Why don't we try to hunt down some signals in here and see how far they're getting? It's a couple of simple things I can do, which I'm going to do right away. Let's get it going again. I can inject some audio into the radio just by touching the volume control in the right spot with my finger. And that should put a hum, should come right through the radio, we should hear it. If we don't hear it, then we can think, oh, the problem must be in the audio circuits. What we'll do then is we'll look for radio signals in the radio up to the output of the IF, or maybe even the input to the volume control. Let's see if there's any sound there. Okay, so we're running with 115, 114 volts. The volume's up full, we don't hear a thing. I hate saying that, to be honest with you. The input to the volume control is right here. The output is right here. Severe weather alert for Aurelia. Warning. Environment Canada has issued a heat alert for here. It's probably actually for tomorrow. They're just warning us today. So volume down. Injection. That's injecting it right into the output of the volume control. So basically into the audio signals, and we're not hearing a thing. Not a thing. This is a push-pull radio. So you've got 4 tubes involved in the output. Any one of them, I believe, it could fail, and you'd still hear some stuff coming out here. It just would be distorted. There's no sound coming out at all, which really indicates loss of B+. Now we know there's B+ in the power supply, at least one part of the power supply. I didn't check the other part. Let's do that. Gee, I thought I was going to be working on the tone control. You never know what's going to happen with these old radios. So we're going to look for B+. First, where I found it before, just to verify the test. It's right here. And the other high voltage terminals right here. Wow! 373 volts. That is high. That's high, even in these radios. Lots of voltage. voltage on some of the audio output tubes. And we will look for that. Here comes an assistant has arrived. Who's arrived here? Why, it's Wally. It's Wally who's come. Wally is a man of action. Well, he's a cat of action. He's usually got something in mind. He doesn't like hanging around. He likes doing stuff. My other cat likes hanging around. But you know what? This is a little dangerous for you. Yeah, this is a little too dangerous. Wally, go down. He's gonna do it. No, he's not. He's gonna start playing with these wires. Come on, over here. You see this door over here, Wally? I'm gonna throw you through it. Come on. You gotta go, buddy. You gotta go, man. Oh, there you go. Oh, there's another cat in here. Okay, you go too. Oh boy, they were both in here. Concentration. Concentration. We're gonna look for, we know where the plate is here. This is the plate. 200, you can't see the voltage. It's 268 volts on the plate there. So no lack of voltage in this radio. Why, so we've injected audio, heard nothing. Finding the voltages. Tube testing, I gotta go switch to tube testing already. Let's listen and see if there isn't audio here. They just can't make it any further. The easiest way to do that would be to turn this guy on here. So this is basically an amplifier and a radio receiver, depending upon how you set it up. I'm setting it up as an audio amplifier. That thunderous sound is cats right above my head here. There we go. Just wasn't warmed up. So we would expect to find audio on the input to the volume control. So I'm going to keep my hand on the volume controller. Let me just turn the camera just a wee bit further so you can see all the controls that are on here. So volume control. This is a this controls the input, if you like, and this controls the output. You can put it that way. Anybody home?
It is 21 degrees at Pearson with a humid X near 26. 680 news time at the tone 10 o'clock.
Number one for breaking news.
What's the breaking news?
And weather. 680 News Radio, Toronto.
Good morning. This is Saturday, June 21st. I'm Chloe Bernabé.
I'm John Leatherby. Here's what's making news this hour.
What?
Lots to do on this first day of summer. From music to food and cultural festivals, we'll have your full weekend rundown straight ahead.
Where's the news?
National Indigenous Peoples Day today, and the GTA celebrating with plenty of events.
We're turning up the heat in a big way to start off the summer season, but how hot does it get? I'm meteorologist Carl Lim.
But
Your
don't tell
full
us.
forecast is coming up.
Yeah, I won't tell you now. You'll have to wait to hear me later with a bunch of ads in between. National Indigenous Day today. The Indigenous population in Canada is very significant. It's not a small portion. It's a significant portion of the Canadian population. Here's some numbers. I don't know for sure that they're right. I think it's 16%, but I'm not sure about that number. And in the United States, it's only 3%, which is vanishingly small. So, okay. Let's see what we can do here. Audio at the volume control. So the audio must leave the volume control. Let's check. Is it leaving the volume control?
Disabled vehicle.
That's right. Yeah, that's right. I got my turn down, turn up thing back.
Volume to 427.
Okay. So it's coming down this cable, and it heads up to the grid cap on a tube I can't really access right now. So anyway, we've done enough to know that the radio's operating. It's producing audio. The audio is leaving the volume control. From there, something is going wrong. leave the volume control and it heads straight into a amplifier tube, and then part of the output of that tube is fed to the inverter tube, which is what causes the inversion, by the way. And then the inverter tube inverts the signal so it's upside down, and then the two opposite signals are sent out to the push-pull tubes, and then their output is combined in the output transformer. Well, I did all this hand stuff, but the camera was over here. That's okay, it was stupid hand stuff. Well, how far does the signal get in this radio? The next stop would be grid of the. This is going to be a little bit of a problem here, unless on that diagram. Let me just peek at a diagram here myself. This is the layout diagram. Do they tell you the pin numbers? Oh, they tell you the functions of the pins. Okay, that's perfect. That's actually helpful. Okay, I'm going to stop for a minute and rearrange things a little bit camera-wise here. This might get a little hard to follow as I work my way through this, but we are hearing the audio here at the output of the volume control. From there, the volume control output goes over here. I did notice muting. The muting takes place when the motor is operating. They take some of the motor voltage, rectify it, and then use that to over bias a tube or two or three or whatever to cut the sound off. Somewhere they cut the sound off with bias derived from the motor voltage. So is the radio in muting mode right now? I don't think so, but that's a possibility because it's so silent, and we know the muting works because I've run the motor and the radio does go silent just like it is now. So if we look down here at the motor then, just for interest's sake, we can probably see some wires coming up into this area here. Here's one. See, this is the rectifier here. You can follow this wire. It goes all the way back to one of the motor windings. So without going any further there, that's how that works. But the motor's not on, so there's no voltage, so there's no silencing bias. There should be no silencing bias. So the audio comes out. The next place to pick it up is at, oh, look, right on the grid cap of this 6F5. Now I need to locate this correctly. Actually, there's two 6F5s, and both of them have grid caps, and both of them should have signals on it. So either one of them. So either one of the two 6F5s. Okay, so just to make sure I know what I'm doing, well, to try to make sure I know what I'm doing, other end of the radio here. What are the 6F5s? 6F5 and 6F5. So the two in the corner down on the bottom. So those two, I should be able to find on the grid cap of those two tubes the signal. One of these tubes is a tube I changed. Wow, this is really it's really pointing to something, isn't it? Okay, so I will inject signal at the grid caps. I've already done this by touching them. Let me do this again. Here, let me go back to the camera. Okay, so I'm going to repeat what I did before. Volume up. Grid cap tap. Nothing. Nothing. Nothing at all. Nothing from either one of them. What stupid thing am I doing here? I am doing something stupid. There has to be something stupid going on. Is the speaker not plugged in all the way? Sure it is, because yeah, fill coil's warming up, speaker's making sound. Speaker's got to be plugged in all the way. So the signal should be present on those grid caps. It may not be getting further through the radio, but it should be there. We should be able to hear it. With this guy, if I can't get him up there though. So we're going to have to extend this, which is probably going to introduce a lot of noise. Let's see what happens if I put basically an antenna on this. A little bit. Okay, I need my hand free for the volume control. Need a longer clip lead. Need a long one. Where's the long one? Here's a good one. Okay, I can put that down. Okay, and on the volume control, one then the t'other. That's one, and the other. Wait a minute, now the output comes, just a second here, what's going on?
Second breast value pack for only $4.
You can see the cable heading down, goes through a hole onto the top of the radio, comes up, and oh, I'm on the wrong tubes. I'm on the wrong tubes. I'm on the wrong end of the radio. Oh man, alive. You see, I'm only partway through the first cup of coffee. Okay, so that test meant nothing. None of those tests meant anything. I can go back to using my finger. Back to using my finger. Oh, I gotta reach around here. Here, stand over here, would you please? This will probably make sound now, because I'm doing the right thing finally. Nothing. Ooh. Okay, I got one of them. Oh! Guess what I found? How many times I have to fix this radio? How about that tone control? I'd say no difference whatsoever. Well, grid cap again. Why am I all spun around here and gone crazy? Did I have the radio tipped up the other way the other day? No, I've always tipped it up with the transformer down. Okay, I got it straight now. I got it confused in my head that I changed the tubes that are located down here, but no. It's up here, yes, the RF tube got changed. Everything's fine. Audio's fine. This is a different problem now. This is a different tube. All I did, by the way, is I just put my finger on the grid cap and just tapped it, and that mechanical action brought it back to life. So it's another grid cap problem. Okay, I'm going to turn off my tracer here because it's humming away. Get rid of that. Lovely.
Behind you, a two-story cottage nestled in the trees. Is it your imagination? Or is it your possible? Find your possible. Play Lotto 649 for a chance to win the club.
Okay, back to the tone control. I deal with this tube problem with the cap appears to be something going on with the tube, but I can't right now. It's just too far around them. Let's just focus on this tone control deal. So there should be output reaching the tone control that I can pick up with my machine over here, which I turned off. I'll turn it back on. Now the difficulty is this speaker is going to be making sound too, so I'll have to vary the volume on the other. Well, what did I say it was supposed to be? I forgot what I was doing. Yeah, what's on the tone control? So if I introduce resistance here by turning this control this way, then I should be able to pick up the signal at a large voltage. Well, actually, it's protected by a capacitor. I should be able to pick up the signal here. That's the theory. Am I right? There it is. Now, just
A bit of a delay. Highway 7 is up to line. That's pretty typical. And then from there, looks pretty good. Starting to
So as I turn this control, I'm reducing the resistance between the probe and the chassis. There's a resistor right now in the volume control, in the tone control. As I reduce it, I'm just basically grounding out that connection. Seems perfectly fine. Okay, now, so the signal is getting right through the capacitor. Explain that. Okay, you know what? We're going to leave that alone. Say, okay, I don't know what's going on with the tone control. I can't, nothing makes sense. Don't know what's happening. I'm going to leave it alone. Now we should go back to the capacitor I removed down here and see about reconnecting it and see what difference it makes, because it really should be in there. So we're going to try to do it temporarily with these. They have a rubber handles, but by the way, when you grab them like this, you've now become a capacitor. You're a plate, that's a plate, and that's the dielectric in between. So bear that in mind. Okay, so we want to grab the wire and touch it. Grab the wire, and don't touch anything else. Grab the wire, touch it. They say there's no noticeable difference in the operation of the radio. But we could assume that it's draining out some RF. Hey, why assume? Why don't we take a look? Why don't we do a little experiment here? What I'll do is I'll get my oscilloscope going. We'll attach it to the point where the capacitor is supposed to be. That's the output from the first audio amp. And we can see if there's any high frequency in it. We'll try anyway. And knock on the capacitor and see what happens. So we'll see what happens on the scope here. Okay, I'm gonna get that set up. So it just took me a minute or two just to turn on my oscilloscope and connect this lead to it. And when I turned up the volume, nobody's home again. So I'm gonna repeat the tap. Please step to your left here. Repeat this deal here. This guy. Yep. What's the tone? What? What happened to the volume control? Can't be the scope. No, can't be the scope. The volume control is no longer doing anything. Come on! Oh. What is going on here? So I'm guessing the tube, the contact it's not make and break. It's making maybe half break and half make. It's weak or something. I don't know. Let me poke more at it with a stick here. Yeah. She's in trouble. I have to get a new 6F5 and replace this one because obviously even if I get it working, there's no reason to think it's going to continue to work at the rate it's going. Is it just the wire or is it the tube? I can't tell from there. Okay, we got to do something about that. What about my test right now? Can we? Let's carry on. We can still do it here. So what we're looking for is high frequency stuff in this signal. And I don't see any. There's a hum in there, that's for sure. I don't see any high frequency stuff at all.
Up to 40% off select mattresses. And up to 25% off bedroom packages, dining packages, won't be.
Well, one of the things we can see, I'm going to put a better camera on the scope because we have a chance to do something else at this point too. So let me get a better camera going on there.
Friday deals must end Sunday. The
Presented by Rogers. Please play harder. The cans play harder. Welcome to the Tennis Playground. Get your tickets now at nationalbankopen.com.
Okay, so there's the hum. I can't really hear it. Here's the signal, about the same strength as the hum. What's interesting now is if I turn the volume up until this gets big enough, it will start hitting limits. And up at the top of the signal, or maybe at the bottom of the signal, you'll see that the nice curve, I'm just using the AC thing here for demonstration, the nice curve will get flattened at the bottom. All the signals that come down there will get chopped off by being pushed too hard. Well, let's see if that's really true. It's going to get a little loud in here when I do that. Here we go. Here we go.
It's time to celebrate Foodland's 40th anniversary, proudly sharing what locals love with our neighbors since 1985.
Your trusted News 680 and News Radio with CFTR AM Toronto. Felix, what is the most...
Okay, so I could see at the top the peaks were being flattened off, so it's reached the limit of a tube. The tube can't do more. It's being asked to do more, but it can't. The bottom is not chopped off. The bottom looked okay. That indicates that the bias is not quite centered properly in the tube. But that was with the volume turned way up.
Jazz Fest and concerts by Tom Art.
Now, I'm going to do it again. I'm going to try. Oh, son of a gun. Scare you? Scare me. It was nothing more than the speaker dropping an inch. Okay, nothing happened. Nothing bad happened here. Everybody's okay. I'm okay, just more perspiration. That's all. I'm going to turn it up, and as soon as it starts to show the flattening at the top, I'm going to listen very carefully and try to learn what that sounds like. So I can identify without a scope, just by listening. Let's try it and see what happens. So this is normal.
Canada will take on Curacao in the Gold Cup tonight. Sports at 45.
City News Time, 10:31.
Time for Rogers Xfinity Internet traffic and weather together on the ones with Brandon DePont.
Thank you very much. And right now, just looking at a pretty busy drive across many of your major highway routes. As support brought to you by Shoppers Drug Mart. So delays certainly developing eastbound 401, but this more of the...
So I would say listen to the S's. Usually it's this sound that really gets distorted and you can hear easily. So I'll play it at normal level, then I'll crank it up, and then just listen to what happens to the S's in the guy's voice.
From the 404 to Avenue, alternately in the Express and Collectors, and from Kiel, alternately in the Express Collectors towards Dixon, northbound DMP. That's going to take you a while for approaching Don Mills to Lawrence. Southbound...
I'd say myself, and maybe it doesn't sound, maybe you can't pick this up on the video, I don't know, but I would say it goes from sounding very clean, like, to sounding like that, more of a shushy sound to it. Could you recognize this when working on a radio or something, or an amplifier? Just recognize it? Well, if it gets really bad, oh yeah, you can definitely recognize it. This is hard. This is hard to hear for human beings because the harmonics that are being generated are kind of natural and kind of fit in with the sound, and we don't really pick up on it that well.
You will start to notice delays and be stuck in a bathtub from Parkside. Now, going over to city streets, good news to share with you. Shepherd and Sentinel, that intersection has been completely reopened following...
Well, isn't that great? Let's open up that intersection. The car makers are doing everything they can to sell cars.
Like every star that's out there. But if you just take a step back and say, are what these guys doing good or bad for sport? They're not making other teams bad. They're actually showing people if you want to win, if you want to build the winning culture, you got to get good players.
You know, in fact, this is a push-pull radio, so what it's probably showing that it's flattened on the top but not on the bottom is that of the two. There's 4 tubes involved. Probably only one of them is being pushed to its limit, and that would be only affect one half of the signal, because you have 2 tubes affecting the top half and 2 tubes affecting the bottom half. In fact, you know what? Actually, 3 tubes affecting one half and 2 tubes. Okay, that doesn't make sense. Makes sense to me. Okay. What can I tell you? Well, That's not really a problem to worry about because I just don't think it is. What is a problem? The problem would be that tube. Okay, I'm going to switch things around so we can go after that problematic tube. And maybe I'm just confused. It's the same tube as it was before. I'm not sure. Oh, sorry. Does that happen to you? Sometimes I move my hand or my finger or something, and I get a little zing, just a little nerve pinchy zing thing. But when I'm doing this work and I get one of those zings, I think it's an electrocution happening. I tend to overreact. Yes, an electrocution is taking place. Okay, I have to spin this radio around so we can work on it properly. So I'm going to do that. Okay, let's just take a look at it. It's not on. I don't have the speaker plugged in or anything. But let's look at this. Look at this tube. It's not seated. But this is the one I was touching. This is the one that was acting up. So I don't know if you can see that or not. It's just like another tube in here. There's a brown non-conductive insulating piece here right on the top of the tube, and then the metal part of the tube has been kind of curled over it to hold it in place. And then this cap is sitting on top of this brown material. There's a wire coming up right through the glass. There's glass inside here. This is a glass tube like all tubes. The metal is more like a shield and certainly a protection, but there's a glass tube inside here. The wire's coming up through the glass, protruding out, and then this cap, this part here has been soldered onto it. That's the construction. So you can see that to some degree it's dependent on this wire coming up, but they apply glue to it in various places in various ways. I don't know really. Do they do that, or do they just rely on the crimping of the edges here to hold this plate in place? Because they know this is going to be on and off. They know people are going to twist this on and off. They know what the tube is going to be subjected to. So I think they use a fair bit of glue to kind of hold this all down. Of course, this piece is soldered onto the wire. The wire is quite long at first, and when they put the cap on, the wire sticks up through it, and they solder. Then they nip the top of the wire off. You can see the top right here. A little bump right there. It's probably where the wire came through originally. Oh, is that a cold solder joint? Has that become cold? We need to take a really close look at this. So to do that, we're going to get our other camera out here. And where are you, camera? Sometimes I have to look at the image on my, it's up here, on my computer to find out where the camera is. Okay, all tangled up here. Just bear with me a moment. Okay, so that's the camera there. I'll switch over to it. And it's looking right at the tube in question. Can't really see. You can see the whole brown piece is turning. So the cap is probably glued to the brown piece. And is the wire moving inside there? Oh, it doesn't look like it, does it? What now? The other thing it could be is where the wire coming up right back here just a wee bit. Let me just tip this up a touch. Where the wire comes into these, as I was explaining before, these are often steel. And the reason they're steel is because they want spring tension in the clip part. They want that to be squeezing down, squeezing down. Steel has springiness to it. Many other metals do not. Copper, for instance, there's no springiness in copper. So if you made this out of copper, it would never hold on here. It would just eventually come off. You couldn't do it. Problem with steel is you can't solder a copper wire to it. So what they do is they crimp this. Now in this radio, they've gone ahead and applied solder. You can see the solder in here. In fact, you can even see the strands protruding through. So they push the wire, the bare wire, up through the thing. You can see them sticking out. Surely to goodness, this isn't the problem. I don't know why I asked surely or goodness. what I did. So I think it's extremely unlikely that the wire connection to this is the problem. The problem is going to be here. So one option is replace the tube. That's a good option. Another one is to try to resolder this top. Should really operate the radio and demonstrate the problem very clearly before attempting a repair. In case I'm full of crap and the problem is not really what I thought it was. Okay, I gotta get the speaker back. So the radio was on for quite a while this morning, and the field coil I'm holding right now in my hand did warm up, but that's normal. This is just a little bit warm, and that's quite normal. There's a fair bit of currents going through the field coil, and there's a lot of wire in there. So it's bound to generate some amount of heat. Okay, we have that on. So the objective here is to fiddle with this while the radio is operating and make the problem come and go. And then we can examine more closely what it might be, but I don't think there's too much more to see, frankly. Okay, so the radio is on, and the power's coming on here. Coming on. Very good. Whoops, there. See, my camera just suddenly, it just decides, I'm not sure why it does that. It just decides to stop. Maybe the wire going into the camera is a little wonky. Ooh, it feels as solid as can be. I don't know. I have to keep an eye on it because you see the camera can stop and I may not notice. And I carry on here for quite a while when there's just a still. There, it did it again. You know, I'm bumping this connection down here. Okay, time to experiment with the camera briefly. Let me reset. Okay, and that's definitely there. Yep. And now I'm wiggling a little connection here. Still there. I don't know. I don't know what it is about this camera. Lovely image. But it's coming with this other problem. Okay, we're not hearing anything. Very, very low volume here. I'll take my chance to breathe there. Now we're back to the low volume thing. Well, maybe it's this too. Just fool with the tone. Make sure the antenna's connected. Oh, you know what it is? Look at the dim bulbs. I'm still on dim bulbs. So we're running the radio now with 77 volts and it's working. But we're going to run it with 115.
Go get them. Thanks for listening to Sportsnet Today on Sportsnet 590, The Fan.
If I'm cooking my... turn this down. Lots of volume now. I'm not cooking my camera here, am I? Probably am. Okay, here we go. We will now experiment. How much on it? It's not going to do it at all now. Maybe it was this. I didn't push this tube in. Oh, come on. Well, I think I know what the problem might have been. Power off. Okay. Push her down. Push her down. Way down. Way down there. That was probably the problem of the stupid things that going on through my... Okay. One pop. Oh, did you hear the volume peak up there just for a moment? Is it the wire or is it two?
I'm a retired NHL player. After 18 years, my knees and feet had just had enough. Day to day was filled with some sort of pain.
I was explaining about the, I can't show you this, the handles of these pliers turn into capacitors. But does it matter? It doesn't. I think it's the cap. Is it the tube?
And fast.
I need Indeed.
Indeed you do. When you sponsor a job on Indeed, it's easier for talented candidates to find it, which makes it easier for you to hire them.
No.
Visit
I think it's the tube
Indeed.com/claim
cap.
now and get $100
Okay,
towards your first
so
month.
we can try resoldering this and see if that helps it out. I gotta let it cool off just a little bit before I start handling it. So good time to go and drink a little bit of coffee. Okay, let's get the cap off here. So I was looking at the weather forecast for the next couple of days, and they mentioned something called the Ring of Fire. Ring of Fire. So there's an area up north called the Ring of Fire. That's a different thing. That's a mineral discovery that's been made in northern Ontario. Of vast mineral resources in a remote area. But the Ring of Fire is, you get high pressure forming over top of the United States. Here's the United States, kind of south of where I am, south of the Great Lakes. And then you get a airflow going like this, and this up where I am. My hand is going over the north side of the Great Lakes and down in towards Toronto, kind of where I am. And this can set up a chain of heavy storms that can just follow this pattern for a few days. We can end up with an awful lot of rain. Yeah, right. You know, weather reporting. I don't know how other people feel about it, but it can be pretty bad here. Okay, so I'm just going to melt the top of this and stick some more solder on it, and we'll see what happens. I have my solder. Here it is. There we go. Camera to the floor. I mean, now this could have an effect of making things worse easily. Could easily do that. I can feel the wire with the soldering iron. Okay, we got a little bit of a protrusion here. I did get rid of most of it. Okay, now this will probably still be, well, doesn't seem to be. Okay, don't flex it too much, generator. Undo what you just did. And we'll put this guy back on. Must be steel with some kind of plating on it, because it's not rusting. It's obviously not naked steel. So it must be tin-plated steel, or maybe some more appropriate material. I don't know what it would be. Silver. No silver. Okay, we're ready to operate the radio again. So we have everything set. Good. Okay, everything is set to go. When you say set to go, wow, somebody could interpret that a couple different ways, so it could be a bad way. Okay, we're going to go full voltage here.
And people that have played for that organization in the field.
Lots of volume.
They're rooting that team on. The way they've gotten behind this team has been crazy.
So let's start with TJ McConnell, because you mentioned him. There's an anticipation, like you said, that when he checks in, he's going to do something crazy, and it may be stealing an inbound pass, it may be a baseline layup that for some reason OKC just hasn't really caught on to yet, although I can say that. They closed off a few times, but he's still getting to the rack. hitting some of those 4-foot fall-away jumpers. But his impact on this series, can you describe like what it does for a team
So,
when a person off the
my
bench
hand,
is
so this is
providing
the
that kind of energy?
capacitor effect I was talking about. Okay, I'm not going to touch that directly, but I'm holding onto this tool, and so there's a capacitive effect between my hand and the metal part, and so we can conduct. And of course, me standing here, I'm full of hums. I'm full of hums. Some of them can get through as if I have a capacitor connecting me to the radio. I'm hummy. Okay, I think I solved this. It seemed pretty rugged. I beat it up with a little stick. It didn't seem to have a problem. So I think I'm going to stop here. The radio's very stable now, I believe. And I think what I want to turn my attention to tomorrow, and maybe this will be the last bench thing, is sorting out what's going on with the antenna. And experimenting with the loop antenna and other antenna connections at the back, just to see how it all works. So that's what we'll focus on tomorrow. So thanks a lot for watching. As I mentioned to the owner of this radio, the very end of these projects, especially a big one like this, it can have a long tail. Just little things keep showing up, and it can go on and on and on for a while. So that's kind of what's happened here. But I think I'm at the end of the tail. Fantastic. Thanks a lot for watching, and go have a great day. Today's going to be okay here. Tomorrow is going to be thunderstorms and rain from the Ring of Fire effect. Yeah. See ya.